Alright, so we're going to do problem from chapter 4. The first problem we're going to do is problem 7. An iron's position vector is initially at here. So let me just write down. Your R here is 5i minus 6j and then plus 2k. And then 10 seconds later, it is changed to this. So I'm going to say that R prime, so that is negative 2 I hat plus AJ hat minus 2 K hat in 10 seconds. So I'm just going to leave the 10. So T here is 10 seconds. And or in meters. So these are the position vectors, and time is given. In unit vector notation, what is the average velocity during the 10 seconds? So if you recall, the average velocity is defined as delta R over delta T. So the displacement over the time interval. So then it becomes quite straightforward because you have your R prime, so your delta R should be R prime, the final position, minus initial position, and over the time. So what we have here is that you have negative 2 minus 5, that's your I hat, and then divided by the time, which is 10 seconds. And then the next one is 8 minus negative 6. So I'm just going to keep like that. And then over the 10 seconds, and that's your J hat. And then you have negative 2 minus 2 over the 10 K hat. So what we have here is that the average velocity is equal to negative 0.7 I hat, and then plus 1.4 J hat, and then minus 0.4 K hat. Okay, and these are in unit vector notation. So your average velocity is equal to this, and the unit, of course, is meter per second. That's what we have here. Okay, now, what about if I ask you to find out what is the magnitude of the average velocity, or what we call the speed? In that case, you have the x, y, z component. So your speed, or the magnitude, would simply just be the negative 0.7 square plus 1.4 square, and then plus negative 0.4 square. So what we have here is that you should have a magnitude that is 1.68. Now, of course, you can also find out the angle, but because it's three-dimensional, finding angles will be challenging, so you don't have to do that. Mostly, we'll be dealing with the situations that are in 2 dimensions. Okay? All right, so this is problem 7. Now we're going to move on to another problem, that is problem 22. So let me just erase this. All right, problem 22. A small ball rolls horizontally off the edge of a tabletop that is 1.2 meters high. It strikes the floor at the point 1.52 meters horizontally from the table edge. How long is the ball in the air, and what is the speed at the instant it leaves the table? Right, so the initial velocity is not given. We're given the height of the ball. We're given the the horizontal distance that the ball traveled, but we're not given the initial velocity. Okay, and it says that it throws horizontally. What does that mean? Because in the problem it says that the ball rolls horizontally off the edge, which means that you should have the non-zero horizontal velocity and also a 0 vertical velocity initially. Okay, so whenever you do this kind of problem, it's always recommended that you draw a diagram and then associate the numbers with the symbol, so you know what goes, so you get a better idea of what's going on. So let's say this is the table, and this is the floor, and this is, the distance. So again, by convention, we usually define the lowest point to be 0, and then anything above is is positive, anything below is negative. So now let's say this height is 0, and then this height is, let's call that initial height. It is at 1.2 meters. Okay, so you have the ball here and it's moving like that. But of course, when you have initial velocity that's going right way, it does not go right way. It actually traces out a trajectory motion because it becomes a projectile. So you have the ball that's rolling like that and just going down like this. So let's say at this point you have the origin 0, 0, x position and y position, and the y position is 0. And then this one, this is the final position, horizontal position of the ball, which is 1.2 meters. Okay, and so we have initial velocity in the horizontal direction, which we do not know, and we know that the vertical velocity initially is 0 because it's rolled horizontally. And so when you look at this is a two-dimensional problem. So this is a projectile motion, as I mentioned in during the lecture. Horizontal motion and vertical motion, they are independent of each other. So so whatever equations that works for the horizontal, should not be confused with the equations with the vertical. Okay. So we know that this rolls up. Why is it going down? It's because in the vertical it experience a non-zero acceleration. So we can say that your AX horizontal acceleration, we know that there's no acceleration. But in the vertical, there's a negative g that the ball experiences, okay? And you asked to find the time. You asked to find the time when it rolls up at this point. So let's look at the information that we have here. We have the separation, the vertical separation. We also have the horizontal displacement. And we could have used, and then we do not have the initial velocity horizontally, and you're asked to find time. So what equation can we use based on the information we're given? If you just look through the equation, you'll find that in the vertical direction, in the vertical equation, one of the equations says that the final height is equal to initial height plus initial velocity in the vertical direction times time, and then minus 1/2 gt squared. So let's look at if we can use this equation. We have the final height, we have the initial height, this term is 0, we have everything to that we have to solve for the t. So let's do that. So you have your x, the final position is 0, and your initial position is at 1.2. There's no initial velocity, so it's minus 1/2, and your g is 9.8, and then times t squared. So just by solving this, you can easily solve for your t. So your t, how much time it requires to, when you reach that point, it basically, after punching the number to calculator, you should get 0.494 seconds. This is the amount of time for the ball going from this point to that point. Okay? So now the next question is, you're asked to find is that what is the initial velocity at that point? Now let's look at the information in the horizontal direction. You have the initial position, you have the final position, and you have the time, the travel time. So it can be easily calculate. So the initial velocity can be easily calculated because we're going to use this equation. The final position is equal to initial position, and then plus initial velocity in the horizontal direction, and then times time. Okay, so you have your x, which is 1.52, and your initial point that is 0, and then plus initial velocity we do not know, and then times the other time, which is, so times 0.494. So after you work out the math, the final velocity, the initial velocity of the ball is 3.08 meter per second. So that's your final answer. Okay? So you have the travel time, you also found the initial velocity of the ball. Okay? All right, so the next question, the next problem that we're going to do is problem 27. And I'm going to erase this. All right, so problem 27. So what you're asking to find. A certain airplane has a speed of 290 km per hour and is starting at an angle that's 30 degrees below the horizontal. So theta is given, and initial velocity or the speed is given, which is 290, but it's not in SI units, 290 km per hour. And then when the pilot releases a radar decoy, the horizontal distance between the release point and the point where the decoy strikes the ground is 700 meters. So horizontal distance is given. Okay, how long is the decoy in the air? So you want to find the time. And how high was the release point? So, so that's based on the information and based on the problem. Let's draw the diagram. Okay, so the diagram is actually given. So that's just, so this is your ground. And this is this is where the airplane dropped the decoy. So that's say, and it's 30 degrees below the horizontal. So you have something like that. So you trace out like this. So again, you can see that this is a typical projectile motion. You have the angle that's given, and then the velocity, because it's going like this. It is below the zero line, so so you have the downward motion. So the vertical velocity should be negative, and you have a rightward motion. So the horizontal velocity should be positive. So initial velocity that is given. We call that vi or v naught. That doesn't matter. So you have the vi here, okay, and the d here from this point to that point, okay, is given. And so D here is 700 meters. So you're asked to find time. You're asked to find how high it is above the ground. So again, we're going to take this. This basically is our final height. So final height is equal to 0. Initial height, we don't know. So let's just say this is your yi. Okay? So now you're asked to find time and yi. So the first thing you should do is that you should have, based on this, you should change the velocity. You should change the velocity into the SI unit. And after you change the velocity into the SI unit, then you have to resolve the vector, because this is a two-dimensional motion. You have the horizontal velocity, you have the vertical velocity, and there's no horizontal acceleration. There's a vertical downward gravitational acceleration. So all this, then they can figure out. So let's do that. So you have this. So you have 290 times 1,000, that becomes meters, and then divided by 3,600 seconds. So what you should have is that you should have 80.56 meters per second. That's your initial velocity. Now, the first thing we do is that let's find out what is our horizontal component, Vix, and what is our Viy. Okay, so let's do that. So you have your Vix is equal to Vi, and then times cosine theta. So in this case, I'm just going to use the small angle notation, which means I'm just going to use a positive 30 degree instead of using the negative 30 degrees. And then so that in that case, you have to manually put a negative sign in front of it if the vector is pointing downward or leftward. Now in this case, horizontal motion, that's rightward. So you have this value, 80.56 times cosine of 30. And you should get a positive value. So your Vix is equal to 69.8 meters per second. Now your Viy, initial velocity in the vertical direction, is your Vi, and then sine theta. And we know that it's downward, so put a negative sign in front of it. And so you should have a negative, so you have negative 80.5. So you have negative 80.56 times sine of 30. So your numerical value is negative 40.28 meters per second. Okay? So now you have the initial velocity. You have the vertical velocity. You're asked to find time. Let's look at what information that were given in order for us to find out the time. you have the horizontal distance that's given. The vertical separation you have to find. If you have the horizontal distance and then you have the initial velocity in the horizontal direction, then it becomes easy to find out the time, because if you remember, x is equal to x naught and then plus initial velocity. In fact, let me just use I here, although they're interchangeable. Ix and then times time. So in that case, your x minus xi, that would just be your d, which is 700. So you have your 700, that's equal to initial velocity in the horizontal direction, which is 69.8, and then times time. So how much time is required after you do the math? Your time is 10.02 seconds. So it takes about 10.02 seconds for the decoy to to go from the release point to the ground. So you got the time. How do we find out the separation? We have the time information. We have the initial vertical velocity. We also have the acceleration. So let me just write down the a sub x is 0, a sub y is negative g. So in that case, it becomes very straightforward, because we can again use the same set of equations of motion. So you have y, that's equal to yi plus v naught vi y t. Initial velocity in the vertical direction, and the minus 1/2 gt squared. So the height of, let's see. So the final height is 0. Initial height is set at, let's say this is your h. So this is your h, and then minus, because your initial velocity is negative, so minus 40. So negative 40.28 times time. And your time is 10.02, and then minus 1/2 times 9.8, and then times 10.02 squared. So after you work out the numerical values, your h here would be 895.6 meters. Okay, so it takes about the release point and the ground are separated by 895.6 meters. Okay, so these are a typical projectile motion. So let me just stop here.